Hello everyone, my name is Mohammed Waid Khan and today we are going to discuss about functions in C++, what they are, how they work and why they are super useful. First of all, what is a function? A function is a block of code that performs a specific task. Think of it like a mini program inside your program. Instead of writing the same code again and again, you write it once in a function and just call it whenever you need it. You might ask, why do we use functions? We use functions to reuse code without repeating it, make, makes code easier to read and organize, fix bugs faster by isolating problems. Now, here you can see on the screen that we have the basic syntax of a function. First of all, we have the return type of the function, then we have the name of the function, then we have the parameters list, and then we have body of the function. This is the example of a basic function. You can see that the return type of this function is int. We have the name of the function, which is add. Then we have two parameters of the function, int a and int b, and then we have this return keyword with a plus b. What the return keyword does is it returns the value of a plus b to the main function, and then we can print the value out. Now we have two types of functions in C++. First of all, we have built-in functions. These are functions like square root and power. These functions are built in into the C++ language, and we can just use them whenever we want. This makes our codes very simple and easier. And then we have user-defined functions. These are functions that are created by users. These are also used to make our code efficient and easy to use. Then we have this example in which we have function declaration and function definition. In C++, first of all, we have to declare a function, and then we have to define the function, meaning we have to add the body of the code into the function and tell it to perform something. So here we can see that we have the int return type, we have the function name add, and we have two parameters inside this function, and then we have a semicolon which makes it a function declaration. Then we have the same thing here, we just add these curly brackets here, and then we add return a plus b, which again returns value of a plus b to the main function. Then we have functions with no return values and no parameters. So we use void function where we don't need the value to be returned, uh, and it just prints out whatever we tell it to print out. As you can see here, it prints out 1st of March, and also this function does not have any parameter, and this is just another type of the function. Then we have an example of function overloading. In here we can see that we are using the same function name, but with different parameters. We can do this in C++. Then we have recursion function. Recursion means that the function calls itself in order to solve a problem. It's like solving a big problem by breaking it into smaller versions of the same problem, and each smaller version of the problem gets handled by this function. As here we can see that we have the int return type, we have the name of the function factorial, and then we have a parameter int n, and here we have an if condition that if n is less than or equal to 1, it returns the value 1, meaning it doesn't go to the recursion, and otherwise else we have return n multiplied by factorial n minus 1, and what it does, it behaves like a loop, and it returns the factorial. So here we have a program. What this program does is it prints out the cube of a number that we give to the program. Here we can see that we have the return type of the function, then we have the name of the function cube, then we have a parameter x, and this is the function declaration, and then we have the main function. In here we have the value of the this variable n, we have given it the value 1, and here we have a while loop, and here the loop says if n is not equal to 0, uh, we enter a number, and we can enter any number, and what it does is it calls the function cube, and it prints out the cube of the number that we give it. And here the function is defined, and we can see that here it returns the value of cube of x. So let's see what is the output of this function. Here it is asking for a number. I'm going to give it 5, and as you can see that it gave me the value 125, which is the cube of 5. Here we have another example of a program. What this program does is it calculates the max of two numbers, and as you can see that the function has a return type int. The function name is max, and then we have two function parameters. Here we can see that we have initialized the value of m is 1, and we have declared a variable n as well. And we can see that here we have a while loop which says if m is not equal to 0, it takes the input of two numbers m and n, and it calls the function max. And then we move on to the function definition, and here we can see that it has a ternary operator, and here it is comparing both x and n, x and y, and we can see that if x is greater than y, then it prints out x, and if not, it prints out y. So let's run the program and see what the output is. So here it is asking for two inputs, so we will input 9 and 4. We can see that it printed out 9. And then here we have another program. What this program does is it gives the factorial of a number that we give it. Here we can see that we have a function. Its return type is long double, and the name of the function is fact, and then we have the parameter of the function. Here we have an if condition, that if n is less than 0, it exits the program, and if not, we have initialized a variable f and gave it the value 1. Here we have a while loop. The while loop has a condition that if n is greater than 1, it goes inside the body of the loop. We have f, and f is multiplying by the decrement of n, and it returns the value of the factorial. Now into the main body we have a for loop which is going from 0 to 1760, and we are putting the value of I into the factorial. And now let's see what the output of the program is. And here we can see that it is giving the factorial of all these numbers. So we can see that the factorial of the last number is very big, so it is not even showing the value of that last number. And here we can see that after the factorial of 9, it went into exponents, and the value just kept on increasing. This is the output of program 3. So here we have the fourth program. Here it calculates the permutation using factorial. So here we have a function named fact, and the return type long, and the parameter n. Here we have the if condition. If n is less than 0, it returns 0 and it exits the program. If not, we have initialized the variable f and give it the value 1. Then we have the while loop which checks for n, and if n is greater than 1, it moves to the body of the loop. And here we have f, which saves the value f multiplied by the decrement of n, and then it returns the value of f, or factorial. Then we have another function for the permutation. Here we have the return type long, the function name perm, and we have two parameters here, namely n and r. Here we have an if condition with or inside it we have n is less than 0, or r is less than 0, or r is greater than n. It prints -1 and it exits the program. If not, it moves to the return keyword, and it returns the value of fact n divided by fact n minus r, which is the formula of permutation. Then we move on to the main function. Here we have declared two variables, n and r, and we take the value of n and r, and then we print out the permutation using the functions. We call the function here and give it these arguments. So let's see the output of the program. So I am giving the value of n8 and r4, and as you can see that it gave me the value 1680. This program works. Then we have another program. It calculates the weightage. Here we have the function the function weight with the return type double, and we have the parameter marks. Here we have conditions. We have if marks is greater than equal to 80, it will return the value 4.0, and just like this we have other values. And in the main function we have a for loop. It goes from I is equal to 40 to I is less than equal to 100, and it increments by the value of 5, and it prints out the weightage uh, by calling the function. So let's see the output of the program. So here we can see that it printed out the value of the function using these conditions. So here we have the sixth program, and in here we are going to discuss passing by reference. What it means: the function gets a reference to the original value, so the changes made inside the function affect the original value. So first of all, here we have the function f, and we are using void, so it does not return any value. Here we have two arguments or parameters, x and y. Namely, we give values to x and y. Then we go to the main function. Here we have two variables a and b, and we are giving them some values. Then we print out the values of a and b. Then we call the function f, and we give them the values of a and b through this function. And what it does is it replaces the value of b, and it does not replace the value of a. Why this happens is and y is a reference to b in here, so changes made to y are going to change b as well. And then again we call the function f, and we give it the value of 2 multiplied by a minus 3 and b. So again what is going to happen is it is going to print out the value of a, and it is going to print out the value of y. because again y is the reference to b here. So let's see the output of the program. Here we can see that the function is working. So here we have the seventh program. Here we have the function named swap. What it does is it swaps the value uh, again using the AND x and AND y. Uh, so here we have float temperature is equal to x. The value of y goes into x, and then the value of temperature goes into y. What it is doing is it is swapping the value of x and y. So here we move on to the main function. Here we have the variable a and b, and what we do is we swap the value of so let's see the output of the program. So here we can see that these were the original values, and then they are swapped by the function. Then we also have the addresses of these values where they are stored, and what basically AND A and AND B is, these are pointers, and by using the addresses of these pointers, we are swapping the value of uh, these variables. Then we have our eighth program. Here we can see that it is computing. We have our eighth program, and here we are computing the value of circles. For example, the area of the circle and circumference of the circle. Here we have the function compute circle. Then we have three parameters inside this function, and we are not returning any value. That's why we are using void. uh, so this is the declaration of our function, and after that we are going to the main body of the function. Here we have declared three variables r, a, and c. R being radius, a being the area, and c being the circumference of the circle. Then we are asking the user for the value of radius, and then by using uh, the function, by calling it, we compute the values of the circle, and then we print out the value of the area and circumference of the circle. So here is the function definition. Again, we are not returning, and by putting this formula here, we are calculating the area of the circle, and by putting this formula here, we are calculating the circumference of the circle, and we just call the function wherever we need it, and just print out these values. So let us see the output of the program. Here it is asking for the radius of the circle. I'm going to give it a radius like 2, and here we can see that it printed out the area and the circumference of the circle. So here we have our ninth program, and in this program we are going to discuss about global and local variables. So first of all, what are local variables? A local variable is declared inside a function or a block, like this main function or any user defined function, and can only be used within that function or the block of code. Uh, why do we use local variables? We use local variables to store temporary data that's only needed within a specific function. It helps avoid unwanted interference with other parts of the program. It keeps the program safe and clean. Then we have global variables. A global variable is declared outside of all the functions, like here we can see. Um, it is usually declared at the top of the program, and it can be used anywhere in the program in any function as well. So why do we use global variables when multiple functions need to share and use the same data? We use global variables. It is useful for values that should remain consistent across the program, like configuration settings, etc. Now, if we use too many global variables, it can make our program buggy and messy, because if we change the value of the global variable, it's going to change the value in all of the program, and it can give us errors. So here we are using the global variable. We gave it the value 10, and then in this function we gave x with the same variable value 50, and we are using. So here in this program we have a global variable x, and we gave it the value 10, and then inside this main function we used the same variable and gave it the value 50, and then we print out the value of the local variable and then the global variable by putting two semicolons by sorry by put and then we print out the value of the local variable by just stating the local variable, and then we print out the value of the global variable by putting two colons before it. Then we modify the value of the local variable by just giving it a value, and then we modify the global variable by putting two colons before it, and let's output the program. Where we can see that it is giving us the values of local variable and global variable. Then we have our 10th program here. uh, so here we are declaring a function with default arguments. So here we have a function named repchar, and we are using void because we don't want to uh, return any value. And in here we have uh, two parameters, namely char and int, uh, uh, and we have declared our function here. Then we go into the main function and we recall the function, uh, but we do not give it any parameter here. So it just prints out the default value of the function, and then we give it the equal sign as a parameter, and it prints out the equal sign uh, 45 times, and then we give it two parameters, plus sign and 30. What it does is it prints out 30, it prints out plus 30 times, and then we go move on to the definition of the function. Here we are just using for loop to print out whatever character or number we want to. So let's run the program. Here we can see that it is printing out different values and different signs. After that we have our 11th program, and in this program we are using inline function. So now you might ask, what is inline function? After that we have our 11th program. In here we demonstrate inline function. So what is inline function? An inline function is a function where the code is directly inserted at the point the function is called, instead of jumping to the function definition during runtime. Why use inline function? To save time by avoiding the overhead of a function call, useful for small, frequently used functions. So here we go to the function named pound into kilogram, and here we are using the inline function. It is same as making a normal function, but in here we just add the keyword inline before the return type of the function. Here we have the parameter pounds, and in here we return the value of pounds converted to kilograms. um, After that we go to the main function, and here we have declared a variable pounds, and then we take the weight in pounds, and we just print out the value of pounds into kilogram by calling the function. Now because we are using inline in here, it wouldn't jump straight to the definition of the function. What it will do is it will just replace this function call with the function definition that we have in here. It is just like printing the value of this function in here, instead of jumping into the function definition and then running this whole code. So let's run the program. Here it is asking us to input weight in pounds. We are going to add a weight, and here it is giving the weight in 2 kilograms. After that we have our 12th program. Here we again calculate the factorial of a number. So in here we can see that we have a function named add, and it has a return type int. We have two parameters a and b, and in here we are printing out calling int, and then it just returns the value of a plus b. And here we are doing function overloading. As explained before, we use function overloading by using the same name of the function, just changing the parameters. And in here we change the parameters to float a and float b, and in here it is returning the value of a plus b just in float data type. So in here we have our main function, and we are calling the function add, and in here we are giving it the parameters in data type. So it goes to the first function, and it prints the sum of the first function, and then we give it the values in float data type, and it goes to the second function, and it prints out the value of the sum of a plus b into float. So let's run the program. And here we can see that it is giving out the sum of int and then the sum of float. Then we have our 13th program. In here we are using the static variable as well. So what static variable does is it retains the value of a function. So basically when we execute a program, we don't want the value of the variable to go back to its original value when we call the function. So it just retains the value of the variable when executing the program and calling the function. So in here we have the name of the function fct. We are again calculating the factorial. of a number. Here we have the return type unsigned long and the parameter unsigned long n. Here we have the static keyword to retain the value of I, and we are giving the value of I 0, and then we are incrementing the value by 1, and then we are printing out the amount of iterations here by you called me the value of I and then times, and then we have a condition: if n is greater than 1, it will return the value of the factorial. If not, it will exit the program and return the value 1. Then we move on to the main function. In here we have a variable named n, and after that we have our after that we are just asking the user for a value, and then printing out the factorial of a number by calling the function factorial. So let's run the program. So it is asking for an integer. We're going to just input 5, and it will run 5 times like a loop, and it will print out the factorial of the number 5. After that we have our program number 14, and here we are once again just then we move on to our program number 14. Here we are using the global variable a. We gave it the value 10, and then we have our function. Here the return type is int and the name of the function is set a, and it is returning the value of a. So here only global variables can be returned by reference. So here we are using the reference operator, and then we move on to the main function. In here we are printing the value of a first of all. After that we have declared initialized the variable b. We gave it the value 20, and we are adding the value of b with set a, and set a is just the value a, and it is just adding the value of b into the value of a, which was 10, and the value of b was 20, and it will save 30 in here, and it will print out 30. After that we are just inputting the value of b plus 20 into set a. So b had 30 saved in it, and then we are adding 20 into b, and it will print out 50, and it will store 50, and then we just print out set a, which will just print out 50. So let's run the program. As you can see that a is 10, b is 30, and a is again printing out 50. After that, here we have a program for a blinking LED of Arduino, and here we can see that this LED is connected with pin 13 of Arduino, and it is getting 5 volt from the Arduino VCC as well, and what it does is, after a few seconds of delay, the LED just turns on and then off, and through this basic logic, here we can see that it has declared the pin mode. In here pin 13 is being used, and mode is output for the CPU, and then for this loop we have a digital write function, and here we are just saying that the pin 13 it can be in the false state, or it can be in the true state, and if the condition is true, after 1 second it will just turn on and off the LED. So we can see the simulation here. As we can see that the LED is blinking after 1 second.